Alright, so in this video we're going to go over the respiratory quotient. And the respiratory quotient is the same thing as the respiratory exchange ratio. So it's either RQ, respiratory quotient, or RER. These are the same exact thing. Now he never explains that these are the same thing and he uses two interchangeable terms, but just know that they're the same thing. So if he says RER on the test and or he says RQ, they're the same fucking thing, not different. Now with this number, but we'll just go with RER because that's the more used term. Now what these numbers are is this is a very simple number. It's a decimal from 0.7 to 1, and it's used as a quick glance to tell what fuel our body's using, whether it's mostly fat or mostly carbohydrates or a mixture of both. And in order to derive this number, they take your VCO2, so how much carbon dioxide you're exhaling or is in your venous blood, divided by how much oxygen is in your venous blood. With the theory, or not really a theory, but the idea that if you're exhaling more carbon dioxide than you have oxygen, obviously you're breathing much faster than, or you're exhaling, you're ventilating much faster than you're inhaling oxygen. So if you have a high VCO2, most likely you're at a very strenuous exercise. So this is the thing, VCO2 over VO2. And now he'll probably ask a simple question like, what is RER? And it's just a simple definition like this. VCO2 over VO2. That's just a simple memorization. You might say ACO2, that's retarded, it's VCO2. It's not A. And now, so VCO2 over VO2, very important. And now this is usually a decimal from 0.7 to 1. So we'll say right now it's 0.7. And now what this means is 0.7 is essentially in your venous blood, you have much more oxygen than you do carbon dioxide. So just to play with some numbers, say you have 2 liters of oxygen in your venous blood, and you have 1 liter of carbon dioxide in your venous blood. Now this will never happen. These are very low numbers. That will give you a decimal, so 0.5 in this case. So what this is saying is when you have more oxygen than carbon dioxide, it's a low number. Now, can't just erase some of it, so we'll do VCO2, VO2. Okay, now if it's 0.07, that means you're burning mostly fat at rest. Well, not at rest, but it could be at rest also, but that means you're burning mostly fat. And of course, that will be a simple question. It'll give you, if you're burning mostly fat, that means you're doing a very non-strenuous exercise. So you're jogging for like 5 miles, or you're running a marathon, which is still strenuous, but you're using mostly fat during that exercise. Or you're climbing upstairs very slowly, or you're walking very slowly. You're doing something non-strenuous for a long duration. Your RER is probably going to be, or it will be 0.7. It'll be kind of low for RER scale. And that signifies you're burning mostly fat. Now, when your RER is the example he uses is 0.85, this means you're burning a ratio of 50-50 carbs, 50-50 fat. So you're burning a ratio. So this is when the jog is now starting to turn into a run. When you're starting to breathe a little bit more, it's starting to get more intense. So now the RER starts increasing. And now when the RER is perfectly 1, which is never really, it could be 0.1, but most likely it's 0.9. So when it's between 0.9 and 1, this means you're burning mostly carbohydrates. So now instead of burning fats, now you're burning mostly carbohydrates. Your body's relying on glycolysis, and now you're burning mostly carbohydrates. You're making a lot of lactic acid, all that good stuff. And thus the exercise is very intense or very strenuous. This will be when you're sprinting, or when now an easy run is turned into the last half mile and it's a kick and you're running the exercise is very intense. If you hook someone up to a treadmill, hook them up to tubes and stuff, and you measure what they exhale and everything, most likely if they're running to max, the RER is going to be 0.1 at that instance because they're burning mostly carbohydrates. Now to make it a little graph, because he loves using graphs in this class, okay, this will be RER, this will be intensity. We'll say this is 0.7 and this is 1. Okay, so in very low intensity, you have a very low RER. As intensity increases, your RER gets more. Say this is 0.85, it's medium intense, and now as the intensity gets very hard, your RER is higher. So the end thing to know is the more intense the exercise gets, the higher your RER or RQ gets, respiratory quotient. It's an easy number to tell if they're burning mostly fats or mostly carbohydrates, and most likely that'll be a question because your RER is a very important number to look at. Remember, high RER or near 0.1 burning mostly carbohydrates, near 0.7 burning mostly fats. In between that 0.85 range, they're burning 50-50 carbohydrates and 50-50 fat. Right, that is respiratory quotient.